Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the product after hydrogenation. The product shown is Carlina oxide, which consists of a benzene ring attached via a CH2CH2CH2 chain to a furan-type ring, specifically a dihydrin or benzofuran-related moiety. The full structure of the product is phenyl group plus propyl chain plus a 5-membered oxygen-containing ring that appears to be 2,3-dihydrin fused or a butanolide type structure. Looking more carefully, the product is Z6-phenylhex-2N1 while furan, or more precisely the structure shown is phenyl CH2CH2CH2 connected to a furan ring that has been partially reduced. The actual Carlina oxide is E1-furan-3 vial, but 2N1-1, or more precisely the natural product Carlina oxide is phenylpropyldihydrobenzofuran. Re-examining, the product after adding to H2 is benzene ring, 6 carbons, already aromatic, but the 2H2 reduces to double bonds elsewhere, connected to CH2CH2CH2 connected to a 5-membered ring containing O. Moving on to the next step. Determine the structure of the product. Carlina oxide is known to be the compound with structure a phenyl group connected through a CH2CH2CH2 chain to a furanyl group, specifically Z3 but 2N1 vial, furan or similar. The product shown has a benzene ring plus CH2CH2CH2 plus a dihydrin ring, 5-membered ring with O, with one double bond remaining as shown by the wedge lines in the structure. Moving on to the next step. Count degrees of unsaturation, DU, in the product. The product structure, benzene ring, 4 DU, 3 double bonds plus 1 ring, the propyl chain, 0 DU, and the dihydrin ring, 2 DU, 1 ring plus 1 double bond. Total DU in product is equal to 4 plus 0 plus 2 equals 6. Weight benzene has 4 DU, 1 ring plus 3 double bonds. Dihydrin has 2 DU, 1 ring plus 1 double bond. Total is equal to 6 DU in product. And for the final step. Since compound A was hydrogenated with 2H2, adding 2 moles of H2 reducing to double bonds, compound A has 2 more DU than the product. DU in A is equal to 6 plus 3 equals 9. Weight to H2 means 2 moles of hydrogen added, which reduces to double bonds, so 2 additional DU in A. But the benzene ring in the product is already present and was not reduced. PT with 2H2 at mild conditions selectively reduces non-aromatic double bonds. So DU A is equal to DU product plus 2 is equal to 6 plus 2 equals 8. Let me recount product DU more carefully. The product has benzene, 4 DU, plus dihydrin ring, 1 ring DU plus 1 double bond DU is equal to 2 DU, plus propyl chain, 0, is equal to 6 DU total. Compound A has 2 additional double bonds, from 2H2 reduction, is equal to 6 plus 3 equals 9 DU. Since 2 moles H2 reduces exactly to pi bonds, compound A has DU is equal to 6 plus 2 plus 1. Actually the furan, aromatic, 3 DU, in compound A was partially reduced to dihydrin, 2 DU, accounting for 1 H2. And one other double bond in the chain used 1 H2. So A had furan ring, 3 DU, instead of dihydrin, 2 DU, is equal to plus 1, and one extra double bond in the chain is equal to plus 1. So DU A is equal to 6 plus 1 plus 1 plus 1, furan aromatic, is equal to 9. This gives 9 units of unsaturation in compound A. Why other options fail? 7 is too low, doesn't account for both additional unsaturations from 2H2, 8 is off by 1, 10 overcounts. Therefore, the correct answer is C. Therefore, the correct answer is option C.